So yeah, good morning everyone. Thank you for attending this very early lecture about cloud and edge computing. And hopefully you pick up something new or at least some concepts that could further your research in the near future. So, okay, so cloud computing. We've been in the era of the cloud since I would say for the past 15 years. But the recent boom, I would say 2010s onwards with the proliferation of Amazon. And I would say my first experience with the cloud, or at least the technology behind it, was around more than 20 years ago, no? When I experienced virtualization using VMware, early 2000s, that's 2000, 2001, wherein for my computing life in the 90s. If I need a operating system that I was running mainly at that time, Windows 3.1, 95, 98, and the Millennium Edition. God forbid. And then in the university, we were introduced to Linux. And dual booting the machine is a bit of a hassle. But when we started using virtualization in the early days of VMware, uh, light bulb moment. Wow. Okay. We could run multiple operating system at the same time. A bit slow, okay, but now we don't have to switch multiple hard drives or doing multi-boot, no, or environment. It's now we could run it at the same time. And then fast forward, AWS EC2, basically, a lot of organization, if not most organization, are now using cloud. And you as a consumer, uh, I would say most of you would be using cloud. If you're using Facebook, you're technically using cloud. Using Gmail, Office 365, you're using cloud. Okay, so brief history of computing. In the early days, we have centralized applications running on one isolated mainframe. Okay, this was the 50s, 60s, 70s. They have mainframe, then they have multiple terminals to run and control. Basically, the jobs running on the mainframe. Come 80s, when personal computing was introduced by IBM, this became decentralized. So each and every computer now running their jobs and applications locally. And basically, this was democratization of computing at that time. Then fast forward 20 years after, early 2000s, cloud computing become a thing. And then everyone is now trying to centralize their applications and data in initially data centers, then eventually with virtualization and commodity third-party cloud computing vendors like AWS, Azure. They now started moving everything, well, most of it to the cloud. So, for example, nowadays, running your own email system on-premise, I would say security-wise and availability-wise is a very bad idea. You cannot possibly be better than the engineers running Gmail, where you could host your email domain using G Suite or Office 365, wherein they had a lot of technologies, a lot of optimization that does the filtering for you for spam. The UI is very responsive. Space is not an issue anymore. I still see government institution have 2 MB limit on their email message sending and receiving. So if someone's gonna send a big attachment, they'll have to use Gmail. It's not gonna reach the inbox. No, it's gonna be an exception. I've also seen on-prem, even now, no? Banks, government institution have mailbox limit of 50 meg. I mean, who still uses that? No? So at that point, talo na. No? It's really cloud computing one, at least if you're thinking of the email system alone. No? But other than that, there's a lot of use case in cloud computing that we could basically run yung systems natin. But there are some use cases that hindi rin applicable yung cloud computing. Hence, now we are now attempting at least with edge computing to go back to parang personal computing wherein centralized applications will now be running in environments that's nearer dun sa data generators itself or mga nodes. Okay, but it is in collaboration with cloud kasi something has to be centralized pa nila at this point. So sample of cloud market share, no? So this is second quarter of 2022, very fresh information. $200 billion cloud market. Definitely Amazon, AWS is the lead at 34%. Azure, on the other hand, is following 21%. This is mainly because organization that, for the most part, are Microsoft shop. There's a lot of those. Most likely, you're still using Windows then. Needed a way to manage their Active Directory securely and email system exchange securely. And efficiently, scalable if they need additional resource. So it made sense to them to run Azure. Although some services in Azure, of course, there's a counterpart offering to AWS, but the reasoning that I encounter for organizations moving to Azure and some in AWS is, well, who's better to run, let's say, a cloud-based directory service, no? For Microsoft than, well, Microsoft, so hence Azure. Google Cloud, they still have a share. It's still struggling to get a piece of this pie, not 200 billion market cloud share. Alibaba's there, IBM Cloud, Salesforce, mainly software as a service cloud, is 3%. Then you have Tencent, Oracle, and then maybe the rest. And so mainly winner here would be AWS, followed by Azure, and then Google following closely at third. And with cloud computing, you have, well, three major cloud services. No? So one would be software as a service. So these are systems wherein you don't have to install a software. No? Yeah, you just pay as you go. Ilang license kailangan mo, ilang storage if needed, and then they would just give you a login, then you could manage it from there. Then you could subscribe your users and give the users access to that system. So typical software as a service you would encounter would be, for the most part, G Suite. So a lot of schools are using G Suite for Google Classroom integration. Corporations using G Suite for their email, mobility solutions, communications, even documentation. Kinakalaban ni G Suite yung Microsoft Office with Google Docs, Google Sheets, Google Presenter, and the likes. And that actually had, I don't know, even though the features of G Suite, which is slowly getting there to Microsoft Office level, even though basic yung features ni G Suite, they were one of the first software as a service platform for office collaboration wherein you could have one Google Doc and you have maybe 30-50 people editing it at the same time, making the document generation faster. Not unlike before, you have a document, you edit that document, you send it as version 2 to your colleague, i-edit niya, send niya as version 2.1, edit no isa, version final. Okay, then may comment yung isang boss, version final, tapos may comment yung isa na, oh, hindi pa to final, version final na talaga. Okay, until magulo na, hindi mo na alam yung version, hindi mo alam kung ano in-edit mo na. So, the initial Google Docs release where you could collaborate was godsend, no? For collaboration namin sa office, and then even with my students, when I do teach in the university, some class would have their Google Docs open, tapos kanya-kanyang documentation, and at the end of the class, they would send to all yung document nila about the class and notes, and then everyone has a copy of that note as detailed as they wanted to. And well, you could see sa classroom na rin, no? If may notes, sometimes students would just whip out their camera and take a picture of the blackboard. Used to be taboo, but now it became more acceptable. Hindi pa rin for others, no? But that's slowly becoming how we are teaching in university. So that's basically software service. You don't have to install anything. You just give you access and then you use the service. Infrastructure as a service, simply put, this would be your resource, no? That's such as server storage capacity and network on demand. Okay. And this is where users would build their platform to run application on it. This would be an example would be your EC2 instances, your Google GCP instances, Google Cloud, wherein you are provided with an image and they're gonna instantiate the server, but you need to be the one to configure it, right? For the most part, they learned their lessons from the early days that it wasn't very secure. No? So most images now are secure by default. But yeah, typically it's still the user who has to manage it. Pati patching. They would have to manage their patching, their upgrades, their security. Okay, they just give you a platform, okay, or a compute node. Platform service, this one is where a cloud service gives you permission to manage, develop, testing application, and they provide you sorts of tools through the platform to run and test development on. So I would say maybe Salesforce would fall into this category. And there's other systems like OutSystems, yung mga low-code platform wherein you could, well, they would be considered platform as service and you could build your system there, okay, and ira-run yung load on their backend. To a degree, AWS has something similar for them because, well, the problem with AWS for cloud engineers, every week they are releasing a new product, so it's very difficult to follow, okay, to specialize on it. So there really has to be some specialization per module of AWS sa dami ng products nila. Okay. Then we have three categories of cloud computing. So you got the private cloud. This is where your organization sets up a Blade cluster, may virtualization, may centralized control doon, like you use VMware ESXi for this one. Osen hypervisor with management component. Could also think Kubernetes cluster. Technically, it's not on-prem, no? That would be a private cloud. Pwedeng gamitin dito for private cloud. Basta anything na on-prem, no, pag-aari mo, or pwede rin it's within the data center, no? It's on-prem, but you're the one managing even the hardware. You're doing the purchasing ng hardware, yung pati yung power, pinoproblema mo yung cooling, yung space, yung heat, okay, that's part of your private cloud, no? Kasi you own the hardware. For public cloud, this would be where provider basically gonna install the software on the server, don't have physical access to it. They give you just UI to manage and access the service. Okay, and then once you instantiated some compute instances or whatever platform you instantiated there, you could now remote into it and then manage it. So at that point, you would be managing yung OS. No? So may mga documentation that would say public cloud, like this one, would say that the provider will be responsible for most, no, take note of the operative term, most, no, management, upgrades, maintenance, and security. Okay, but that pertains just to their platform. Yung server load and yung application running on the instances that they provided, that's your responsibility. So they had this shared responsibility model. Now, last would be there is a hybrid cloud wherein this is a mixture of both private and public cloud solutions. So you could have an on-prem cloud syncing to your public cloud, or maybe you have two public clouds. You have Azure for their directory, and then you have your compute instances in AWS that they have to communicate. Technically, that's public to public. But a lot of organizations are still on this route. No? They cannot go full public cloud, so they are on hybrid cloud. Sample. Some bank workloads are not allowed to be published sa cloud. Okay, so they have to maintain it running internally within their infrastructure. But some services, like customer relationship management, mass mailing, okay, marketing, they could host it sa cloud for basically optimization purposes. And yun yung main difference between operating on-prem and moving to the cloud is the CapEx. Okay, you would not have that issue. Everything's gonna be OpEx, so you just pay as you go if you subscribe to third-party cloud. And problem with CapEx now is we do have a global shortage on chips, right? So even if you have millions of pesos, pumunta ka sa vendor now and say that, yeah, I want to buy maybe a 10 rack server cluster. Okay? Kasi I'm gonna deploy some cloud computing research. Vendor would happily accept that price. Note, bagsak din yung peso against the dollar, so it's a bit more expensive. But they're gonna commit sa inyo mga 120 to 180 days delivery, and you need the system now. Okay, or maybe not now, maybe next month. So that's not a viable solution. Hence, a lot of people are also being basically herd down to the cloud option. Kasi, yeah, card, enter your credit card details, fire it up, boom, you have your infrastructure. And we even now have solutions like in AWS, we have CloudFormation or Terraform that you have infrastructure as a code that you could define. How many servers you want, what type of servers are this, resource-wise, how many storage, how many RAM, how many CPU, what OS, what Ubuntu version, what Windows version, what patch level you need it, and then ano yung mga services na yun, pati configuration, it's all in a code. And so, in an instant, not instant, maybe in 15, 30 minutes, you could have a working full office infrastructure in the cloud with maybe 100 kilobyte file, as CloudFormation, fire it up, then bubuin niya yung infrastructure for you, complete with network and segmentation. And that's not feasible if you have running sa on-prem environment. Kasi for on-prem, you have to fire up the machines, install OS, configure them one by one, but pwede rin may orchestration, but besides the point. And then the purchasing part, again, that's gonna be hard. And, well, cloud computing, I'm sure you've heard of this a lot of times. Nahack tayo, di pa tayo sa cloud kasi mas secure yun. Okay? But we do know that's not always the case. I'd say again, going back dun sa shared responsibility model, this one's from AWS. No? AWS only is accountable for this one part, yung sa infrastructure nila. Compute, storage, database, and networking. Okay. Once they instantiated that, it's at this thing is, they are secure by default. It's the client's responsibility now to manage that security ng instance na yun. What ports are you gonna open? Are you patching the softwares in it? Yung software ba na i-run mo doon is fully vetted, na audit, na penetration test, na load test. Okay. That's on you. And that's where the problem lies. A lot of people, not only the Philippines, even abroad, but they had this concept na they could create and migrate their application from on-prem to cloud as is. So it will run, yes, but if the application is not designed to run on the cloud, okay, it's gonna be very inefficient. Okay, and most likely insecure. Kasi you just basically instantiated your server in the cloud with all the vulnerabilities na on-prem. And now, since it's in the cloud, most of them would open it to the public internet, which is dangerous. No? Unlike internally, no one's able to access it unless nasa loob ka ng network. So, again, do note, for infrastructures like Azure and AWS, if you get a compute node, there is a shared responsibility model and they delineate what's their responsibility. So if their database system gets hacked, okay, it would be AWS fault. But if you as a customer are using AWS database and configured the credentials to be very basic, let's say root or root password or admin, and someone was able to get to that database, technically it wasn't AWS who created that vulnerability. Right? It was the customer who configured it insecurely, okay, and leading to the compromise. So yeah, there will be some security issues that will be addressed by AWS. Sample is mga SEN vulnerabilities for hypervisor, wherein AWS would of course have to roll out those patches. And at that point, the customer doesn't even need to be aware that that's happening. It's good to have some subscription to those mailing list for AWS security. So, if something's going on. Okay? But for the most part, AWS migrates your workload to another platform, papatch nila yung parent vulnerable system and then ma-migrate pa kanila doon. So it happens to you seamlessly, pang walang nangyari. So that's cloud in general. Okay, for a short intro. So which brings us dun sa second topic, edge computing. So what's the edge? So kung may cloud computing, bakit may edge computing? So what's happening now is we are trying to make the processing and storage of data as close to those systems that generates them. Because this would have the advantage of better control over data. We would be reducing the cost, okay, of computational power kasi cloud, kada compute mo doon, there is capacity, there is cost involved, and if you could have that data pre-computed on the nodes or computing engine near the nodes, okay, they would just be sending very minimal data to the cloud, mainly for statistics or maybe some other granularized data, not the raw data, which is going to be very big. This would also be able to provide faster insights and action, and basically it would streamline the operation. Okay, so how does edge computing look like with the cloud? So again, they do work hand in hand. So edge computing would still be using cloud, okay, or data center. Okay, and then you have your edge nodes like cameras, automotive system, robotics, radio, turbines, and utilities. Okay, all of these are generating data. Okay, they want to send this data if they cannot compute it on their own. Okay, send it to edge platform near them. So that would mean the bandwidth would be high, the latency would be low, and they're able to process the data here near them. Please may any feedback, they could easily be forwarded to the device agad. And after processing, they could now centralize all those information, process information to the cloud, meaning the data bandwidth requirement for at this segment would be very minimal. Okay, that would make it efficient. So again, edge computing is not gonna kill cloud, no, it's gonna make it more optimized for certain use cases. And how does this work? I mean, camera systems right now, mga IP cameras, they are running mga quad cores. Automotive systems, even Tesla type na autonomous, easy 50 CPUs per car yung mga nowadays mga ECUs nila, no. So there's a lot of computing power on modern devices. So radios sometimes have machine learning and auto configuration using SD-WANs and software defined network. So they have compute capacity there, and this helps basically process the data. Okay, hindi lang sila data generation and then send to cloud. I mean, if you're, let's say, a car manufacturer na, let's say you have 400,000 cars that you need telemetry on. Imagine all of them sending data to your cloud. That's gonna be very expensive. You store and process it. But what if you could pre-process the data dun pa lang sa data generator, okay, with basic analytics, you have real-time data processing, you have data caching, then some machine-to-machine communication, right? Then send out the result sa cloud. That's much more efficient, basically. So edge computing is not new. As I mentioned, used to be in the 90s, no? When 80s and 90s, when personal computer was being spread. It's load is running on workstations, na hindi na centralized as in the 70s with mainframe. But for the network component of edge computing, this was stemmed from content distribution networks, again developed in the 90s to serve videos and others, mga software patches, images. Okay, basically they would want that data that's going to be serving a certain geography to be stored on that location. And 2000s, basically this evolved CDNs into hosting applications on edge servers, And this basically developed the earliest form of commercial edge computing. And siguro isang example I would give here would be, let's say, Netflix. If you're running Netflix, they are running edge computing using CDNs, but Netflix has their own. Wherein they would install servers with a lot of storage on telcos. So they would coordinate with telco. So Globe has it, PLDT has it, probably Converge has it. Page OpenAI would have this server where if there's gonna be a newly released episode of a series or a movie, and they predict with their machine learning and whatever na this country would gravitate towards watching this movie, they could actually pre-seed that movie on their CDNs on that country. Okay, so that when you stream that movie, you're not gonna get the content from some server in the US, which is again very expensive and high latency. Kasi labas ng bansa. But if they preceded servers within a certain country across multiple telcos, and then you log into your Netflix account, click this movie and then stream, the content is already hot. Ready na siya doon sa CDNs. Okay. And basically, the cloud component of Netflix here would just be account management. Okay, that's it. So even the pictures and mini streams, if you choose a movie, it's actually coming from their CDNs, which is most likely located in your telcos or ISPs. So why is computing? Well, this basically points to we want data gathering endpoints to send pre-processed information to a centralized platform, usually internal server or cloud, either via LAN or WAN, maybe both. Okay? And the centralized platform then crunches the data. Okay, but again, these are processed data na. Okay, and if there's any feedback, they send it back to the endpoint. Okay, that's how yung old system, yung cloud system works, no? So you got a lot of dumb IoTs and terminals, use a lot of bandwidth with high latency. Okay, papunta sa cloud and then submit it there and then wait for the processing. Okay, well, that works for a lot of stuff, but imagine this. If you have a fully autonomous vehicle running sa highway, diba? A 2-second latency for any data na na-capture niya for processing, papadala pa niya sa cloud and then ibabalik. Let's say 2-second latency. That could mean life and death. Diba? You need the system to react immediately, and cloud, unfortunately, it's a physics problem. No? Kahit speed of light pa siya, there's gonna be a latency to and from. Aside na pag padala, ipaprocess pa yun dun and then babalik. So you want to solve that latency issue. Diba? What if you already have the compute capability dun sa on-prem, which is, let's say, autonomous vehicle, you have a lot of CPUs there. You could even buff it up. Do the pre-computation there, okay? And then check, diba? Okay, we're running 60 kilometers per hour and then mukha may object sa road, okay? Tao, hayop, bagay, whatever. Okay? Something na immovable or gonna cause system damage. Okay? You want the system to react to hit the brake agad, automatic. Okay? You don't want to wait 2 seconds. Diba? Para ipadala sa cloud and then check na, uy, is this something na pwede nating iwasan? Ano sabi ng sensor natin sa kanan? May kotse ba? Sa kaliwa? Okay? Saan ba yung direction nung object? Diba? Stationary ba siya? Pakaliwa, pakanan? Then we could decide kung saan pupunta yung kotse. So, if everything is sent to the cloud, diba? That's a lot of data to be sent. So, aside from latency to send it, diba? It's the volume of data, sensor data to be sent to the cloud before processing and having a feedback. So, that could mean a disaster, diba? Even with a few second latency lang. For most computing resource, hindi naman real-time yung kailangan natin. That's okay. But for certain scenarios like automated system or let's say plant manufacturing, no? Meron na palang isang sensor that's detecting unwanted pressure. Okay? But it cannot decide on its own. So, papadala pa niya sa cloud with that 2-second latency, that could have mean a disaster na. Diba? Pwede na pala dapat i-shut off ng system yung valve, okay, para ma-relieve yung pressure, okay, but that 2-second work made it not feasible, then sumabog yung mga pipes. So maybe if the system is just a basic sensor tapos walang walang compute capability, there are a lot of cheap solutions that maybe we could put a Raspberry Pi near that sensor para pwedeng mag-react on certain scenarios. I mean, for the most part, we could send it back to the cloud. Okay, but certain instances that would require safety checks, like let's say unwanted pressure on pipes, you could duplicate the data, padala mo sa cloud, but there's a Raspberry Pi that could make the decision for you kung isa-shutdown ba natin yung line or is this still okay within the acceptable limit. Okay, but it's near. So you're minimizing latency with some cost-effective compute node. Okay, so similarity. So na-discuss natin yung sample kanina, autonomous vehicle system. Okay? Basically needs hybrid system and process data close to the endpoint, basically for real-time responsiveness. But you still need the cloud. Again, this is gonna be working hand in hand with the cloud for massive data analytics. No? So dito yung may problema ba yung certain batch ng batteries natin kasi bilis mag-drain. May problema ba yung alternator ng certain batch ng release kasi hindi na charge properly yung mga battery. So those analytics, again, could be sent to the cloud, but they don't require real-time information. No? It's not like sensor data na pag nag-run yung vehicle that you need all those reaction instantaneously as much as possible. It's still not gonna be real-time, but it's near real-time. And the goal here is to be able to react close to real-time. Right? Another issue would be for futuristic use case is the amount of data being generated. Okay? This again would make transmitting and storing all of this information centrally be a major issue. Okay. Well, you have security. No? If you send out all the data, gaano kabilis masisend yun and is the transmission gonna be secure? Well, for the most part, it should be with TLS encryption, encryption on motion at rest. But what if you could compute that data and sobrang liit na data na lang yung kailangan mo ipadala for, let's say, acknowledgement or receipt na ginawa mo itong computation na to. So that could solve some security aspects kasi you don't have to send all those data, raw data remotely. As mentioned, latency, cloud won't be able to solve latency issue anytime soon. Again, even if you are transmitting data at the speed of light, meron pa rin latency yung speed of light and then may pabalik pa. Okay, and then may processing latency pa ng CPU. So that's not gonna be solved anytime soon. Responsiveness, again, corresponding with latency. If you submit a data and then computing pa niya bago pa ipadala sa'yo, you might not have reacted in time. Okay? So you need the compute power on-prem, okay, or near the device that's generating the data. Okay? And then you still have analytics, management, and governance. Accessible automation. Another similarities for cloud is basically telecoms are already implementing network automation at the edge. Right? RF management, power management, or even directionality, no? Using array antenna. Nasaan ba yung mga users natin? Could we actually redirect the beam of the RF towards that certain group of users na mas marami para mas efficient yung transmission nila and mas longer range yung yung maaabot ng base station natin. And then another scenario would be, well, IoT solutions. As mentioned, if the robots needs quick feedback kung tama pa ba yung ginagawa niya or kailangan niya mag-shutdown or mag-redirect. Okay, they need that system to be as close to them as possible para latency won't be an issue and they could perform their job efficiently. Okay. Now, I've seen operations like this that sends data to the cloud. For the most part, it's still okay. No? But there would be use cases wherein they need information near real time. Okay, so the compute node has to be near, if not within that IoT solution. Okay. Lastly here, 5G and SDN, basically enable network automations in telecom domain, while automatic deployment of applications basically would be corresponding to the rise of smart devices, AI may machine learning inferencing, ano yung mga enterprise edge automation na pwede natin gawin. So again, I mentioned yung some sample dito sa telcos where they could predict power requirement to a certain area, geographic area within the base stations purview and using area antenna direct yung energy towards that para mas maganda yung experience nila. Kasi mas marami naman tao dito, as we say. But maybe you could decide. Mas maraming tao doon, pero may VIP ka dito. Let's say, mga Smart Infinity or Go dati doon sa isang side, di ba? So, depends on the rules that you make. Baka ipa-prioritize mo yung mga premium customers compared dun sa mass market. But yeah, that's heavily dependent on the business logic na i-implement ng telcos, basically, of their radio equipment. Okay. This basically also streamline analytics, basically. So edge and cloud networks, they are built for big data analytics. For the most part sa cloud, diba? Everything was just sent and then ka-crunch nila yung information, then they give you some points. Okay, this is how social media system predicts ano likely yung bibilin nitong taong to. So might as well give them a targeted advertisement that's gonna be very relevant dun sa individual. So they said, at least, they do said that, let's say Facebook, they're not technically listening to the mic, but they have very good data analytics across hundreds of millions of people that they could really predict ano yung next na iniisip ng mga tao. So that's their power. No? They had a lot of those data points. So, let's say example, meron kang individual, 30, male, marrying age, okay, good enough income, based sa mga post, heavy traveler. Diba? So, baka interested to bumili ng kotse. Diba? So, advertisean mo ng kotse based dun sa kanyang purchasing power. So, if hindi naman masyado malaki, I mean, good income pero not enough for premium cars, then maybe Lexus, okay, or a high-end Toyota, you could, or Honda, you could advertise it then. But if the system predicts na hindi, malaki purchasing power ng guy na to. So, why not advertise BMW, Mercedes, or Audi sa kanya for purchasing? So, they are able to predict that trend, okay, based on your data points. Processing yung power nito for large-scale edge and cloud infrastructure makes it easy for them to analyze and gain insights from any data set. But again, with edge computing, it's better to pre-process this data on the node before sending it para sobrang basic na lang yung kailangan i-store. And very relevant data lang din for the cloud environment. Kailangan nila i-store and process. Okay, for most of them, again, for analytics, they're using it for advertising. Which is a big money. Cloud and edge, basically, they also have flexible pricing model. It's simply put, pay as you use. Okay, basically, again, everything, most of them becomes an OPEX. Okay, CAPEX is most likely thing of the past. But do note that you need still someone to operate this. I mean, well, technically, people would be part of the OPEX. I'm correct. But hindi ka naman pwedeng bumili ng mga services nito and you don't have any people to actually manage it. Okay? So, again, for costing, most cloud vendors and edge vendors, meron silang pay as you go, meron din silang reserve instances where you could get a cheaper price, but they would be charging you, let's say, for long term. Let's say, bibili ko to for 1 year. Okay? So, kahit hindi mo ginagamit yon, you get charged. So that's how they actually, with analytics, they're already pre-computed na may kita pa rin sila doon. So tingin mo lang nakakatipid ka, pero ultimately 2 months mo lang pala kailangan yung resource. So you don't really need the 12 months, but they get paid 12 months with some discount. So kita pa rin sila. But you, at the back of your mind, diba, you don't have the notion that you would have to justify monthly kung anong gastos mo kasi it was already bought for the entire year with this compute power requirement. And for cloud and edge, most of them would be implementing within regulation kasi they're being deployed to multiple countries. And most of them would have to follow certain regulatory, either data privacy, RF, security. So they would have to comply on those. And yeah, basically, if you subscribe to yung mga big cloud vendors like Google, Azure, AWS, they are already compliant for the most part, no? And if they're compliant in the US and in the EU, you know, chances are they would be compliant on most countries then, which basically karamihan naman nagka-copy paste lang din na regulation from those geographic location. Okay. So that's the similarities. Paano naman yung difference between cloud and edge computing? So to note, when we discuss cloud, computation happens in the cloud. When you discuss edge computing, computation typically happens within the device or near the device, where they call edge server. And this also still communicates to a backend system, and most likely it's going to be hosted in the cloud. So speed and agility, different sila. So basically, edge computing brings their analytical and computer power as close to the data source as possible. This has the feature, or this would have the edge computing ability to be able to respond, diba? Immediately sa isang mga metrics na pinapasa sa kanya for processing. Now, this could also be done on the cloud, okay, but you have a problem. And this is one of the major concerns when we do design cloud environment. Most people would just be computing magkano yung resource, yung instances, yung memory, yung storage, and then compute it for 1 year. Diba? Gawin natin reserve para 40% off. So magkano yan? Okay, we got cost. They do forget that Philippines in general, we have a high rate for bandwidth. Diba? And cloud environment, usually, when yung papasok, like AWS, no? In other instances na walang bayad yung data na incoming, but outgoing data is paid, no? By the gigabytes. Okay? So there's cost for transmitting data. So it's best na konting data lang ita-transmit mo and then have the pre-computation done here. No? So yeah, most organizations always forget the network cost. And even if they do compute the network cost in AWS and Azure, they forget the network cost dun sa side nila. If this is a hybrid cloud, diba, they're gonna be syncing and sending data to the cloud from their infrastructure. They're gonna have to pay telcos for bandwidth to the internet to reach their cloud instances. So that's the problem there. Okay, next difference nila, productivity and performance. Well, edge computing, diba? Again, resources are placed near or in close proximity to the end users. No? This means that client data basically process siya using analytical tools and AI-powered solution within a few milliseconds. Okay? Very responsive, very fast, and you don't need bandwidth basically to send all this data to the cloud, pre-process it, and then have it back. Okay? On cloud computing, well, the advantage is you don't need for racking and stacking. The problem with edge computing is you have to have the equipment on site, no, or near the data generators. With cloud computing, you don't have to rack and stack. No? You just, again, cipher cards, get whatever resource you want. If you have resource, money for it, okay, fire it up, and then now you have data center managed by just software. No? This basically has the productivity of IT personnel, okay? And you allow them to focus on higher value tasks. Kasi imagine setting up a data center, even a small one, that will take months. You haven't even factored in yung purchasing, yung bidding. Okay? With cloud computing, everything's transparent. This is the cost. Okay? Just swipe it in 15 minutes, you have your own infrastructure running for you. Okay. For example, saan nangyayari itong ganito, no? Modern Apple devices, they now have advanced neural engine, okay, or they call it Apple Neural Engine, ANE, no? They started this with iPhone 10, okay, A11 processor. They started this at 0.6 teraflops. So your iPhone 10, which is 5 years old, have a compute capability of 0.6 teraflops. Okay. So they started upgrading this with iPhone 10s 5.4, same with iPhone 11 Pro. But the power now lies actually with iPhone 13, the A15 processor. That consider this 15.8 teraflops. That's 26 times nung previous yung initial generation ng iPhone 10. iPhone 14, if I'm not mistaken, they have around 17.6 teraflops. So not significant from jump from 13 to 14. Okay, but at 17 teraflops, that's a lot of computing power in your pocket. Okay, and now they are using it for audio, video processing and some other machine learning sa mga stats. No? But let's say mga pictures nyo kaya magaganda yung kuha. Okay, they are using this machine learning and computational power to grab all the relevant details, kahit na dark shots, okay, and then combine it and then merge it and then present to you with, well, it's an artificial picture basically, but it's good, it's very good. So sobrang even on low light mode, they're able to capture a lot of those details that wasn't possible before on very basic lens and compute node for storage. So now this is how they do it. Okay, again, well, these are high-end cell phones, no? But you get the idea that at some point this is gonna be normal for most equipment. Okay? Scalability, difference nila. Edge computing, you must account for device heterogeneity. Okay? Kasi if you are deploying multiple device, chances are your first batch might be different from the second, third, or maybe 12th batch. Okay, so they would come varying performance levels, energy consideration, you need to have power. Additionally, edge networks, they operate in more dynamic conditions. Let's say naka-install sa farm, minsan mainit, minsan flooded, minsan malamig, let's say for colder regions, may ice. So this needs to be robust. Well, might look impossible to maintain that, but take a look at your car. Car computers are designed in a way that they could withstand varying degrees of external conditions. Well, for the most part, assuming wag lang mabasa. But init, lamig, moisture, most of them would be able to handle it. You don't have that problem with cloud computing. And with cloud computing, you don't have to buy anything and wait for the deployment. Cloud computing, you just fire it up, dictate whatever you need, okay, subscribe to it, and you would be able to use it. If there's any issue, most cloud computing providers would have different availability, so you could migrate your load, and most of my designs would actually involve multiple availability zones with similar infrastructure that's being synchronized. Okay, so in case anything goes wrong with certain availability zones, easily it's going to be seamless for the users. Zero downtime. Okay, virtually zero downtime. Reliability. Edge computing would have this, I would say, issue sa reliability, because it's a compute node within or near the device. So failover management is crucial. So if the edge computing, maybe not necessarily on the device, maybe somewhere near the device, may redundancy ka. In case anything goes wrong, others could take over the load. Okay? If you configure it correctly, good mesh, good load balancing, losing a few nodes would not be an issue. Okay? And you could basically have total efficiency for this one. So vendors with edge computing, they already have this in mind. Heartbeat checks, health checks, heavy load, someone could take over it within their node infrastructure. So, but it needs to be designed that way. So hindi pwedeng single instance lang na edge computing node servicing everyone. And what happens if that node fails, right? And those nodes usually don't put it on one location, because if that building, let's say, or area gets flooded or nagkaroon ng sunog, you lose that computing power. So usually would have to distribute it across the graphical location then. Well, this in general, cloud computing becomes an advantage. More reliable siya than edge computing because, well, it's centralized. BCP availability zones, it's built in. Less expensive because you don't have hardware to maintain, and which needs a lot of people to deploy and maintain. And copies of your data, critical, you could migrate them or back them up to multiple availability zone and near your location. Pwede may copy ka rin. Sige, gonna be easy. The issue here is you need strong internet connection on both server side and client side to operate reliably. That is being solved by edge computing kasi yung connectivity from the data generators to the edge node, usually short lang yan and high bandwidth. With cloud computing, especially with the current infrastructure we have for the Philippines, questionable yung strong internet connection, especially for far-flung area. Well, we do have Starlink operating soon to resolve this, but it's expensive. So may cost implication. We're not sure how that would work. And lastly, security. So edge computing, basically distributed in nature. You have that data with that compute node, okay, near the data generators. Okay? And nodes could now transmit in between them, mag-communicate sila even without the cloud, to share the load, compute it, and then pre-process it, and then whatever they need, they could transmit it to the cloud securely. Okay? And this also enables you to have the raw data securely stored sa edge computing nodes, and you don't have to send it to a cloud. Basically, to a degree, you enhance data privacy, and it's less likely to get intercepted in motion kasi, well, you never really transmit it outside your country to the cloud. Now, cloud computing, again, it is inherently more secure due to how vendor centralized implementation and management of it. But do take note again of shared responsibility model. Meron na components na doon responsible si cloud provider. The rest, it's up to you. If you install an unsecure software and you expose it to the public, that's on you. Okay? Again, you most likely have heard of this a lot of times. There was a breach, gusto nila maging secure, di pa tayo sa cloud, but they just create and migrate. Same product, no protection, no architecture. They got compromised again, but this time bigger. Kasi once you get access to the cloud and they get access to the dashboard, yung mga threat actors, they would have access to everything. Okay. Another benefit for security ng cloud computing is since it's centralized, protecting data is easier. Okay. And there's a lot of adoption of end-to-end encryption protocol. They even have virtual hardware security modules for encryption. So yeah, that's how difference basically of edge computing to cloud. So I hope, I think this is the last slide. Hope you learned something and we'll be open for Q&A. So I have some reference here. Tony will provide din naman to. Thank you.